This video will give you an overview of using the Admet Universal Tester for the MEE-340 lab. It's important to wear safety glasses whenever you're working around the machine and make sure the safety doors are closed on the machine when it's running a sample. First, we will measure the width and thickness of the sample. You should turn on the caliper and then zero it. Measure the width of the sample. The samples are typically about 13.6 millimeters wide. Measure the thickness of the sample. They are typically about 6.4 millimeters thick. When you're finished with the caliper, turn it off. Next, we'll start the software. The icon to run it is in the home screen of the computer in the top left corner. M-Test Quattro Lite software will open up. Go to the lower right of the screen and in the default workspace, open up the test procedure and select the test procedure for MEE-340 Dr. Wright with Extensometer. If there are warning messages, you should just be able to click through them. Next, go to the top left of the screen and select the Specimen tab. Here you can enter an identifier for your specimen that should include what the material is. Enter the width and thickness of the sample you have just measured. You have to set the home position on the machine to the right jaw spacing for the sample. When you start the software, the jaws may be in any position. We have to fix that. We drew a couple of lines on the sample at about the distance apart we want the jaws. You see they are too far apart. Select the Channel tab in the upper right and click in the Position field to display position in the large window. We will use the up and down arrows in the control panel to move the crosshead up and down. And you can see in this accelerated video, the crosshead is moving down as you hold the down arrow. We go 10 millimeters down. And we can see the jaws are still too far apart. We will go back and run it down another 10 millimeters. Exact positioning isn't very important here, but we do want to completely engage the grip area of the sample. Again, in accelerated time, you can see the jaws move down. We have moved the crosshead 20 millimeters now, and we compare the grip position with our marks. That looks about right, so we'll go with that. We now zero the crosshead position on the control panel. We press the zero button there, which zeroes all of the sensors. Now we are ready to place the sample in the jaws. You have to crank the jaws open wide enough to accept the sample. I like to use a second sample to align my test bar this way. You can use the second sample to adjust the sample location from front to back and top to bottom. Once the sample is aligned and held loosely, you can start tightening those jaws with the cranks. The cranks move those wedges closer together to grip the sample, but now you'll notice that as you turn the cranks on those wedges, they also clamp down on the sample and move closer and closer to each other. It's going to put a compressive load on the sample, which we do not want. As we're tightening and tightening, we will have to continually release that compressive load by raising the crosshead. It works well to have a second person moving the crosshead while the first person tightens the jaws. We have clicked on the load field to have the load in the big display, and we want to keep it near 0 kilonewtons. The up arrow on the control panel is being used to raise the crosshead and therefore lower the compressive load. Negative load is a compressive load on your sample, so we just continually do this over and over again. I was doing it by myself, but this works well with two students who work together. One does the tightening while the other moves the crosshead. Once you are confident the sample is held securely so that it won't pull out when you do your tensile test, you make a final crosshead adjustment, striving to get as close to 0 kilonewtons as possible. Once we have the grips tight, we close the doors on the jaws. Next, you have to install the extensometer. This is a sensitive device. You should not drop it or handle it roughly. We have to make sure that it's not on the sample at the time that the sample breaks. There are two spring-loaded clamps. Pushing them with my fingers causes the jaws to open. There's also a pin that holds the jaws at the starting point. When you're putting the extensometer on the sample, that pin should be in place. Then, do not forget to remove it before you start the test. I find it best to put my thumb in the center of the extensometer and use two fingers of the same hand to open the jaws from the right-hand side. Once it's on the sample, make sure that the extensometer is fully relaxed. There's no pressure either up or down on either of the measuring points. If there's any motion when you remove the pin, you need to go back and reset the position. We are almost ready to run the test. First, zero the input channels. Then, start the test by clicking on the green arrow on the control panel. You can see displacement and load increasing in the lower screen on the left. After a few seconds, the machine will freeze and it will tell you to remove the extensometer. Go in, put your thumb in the center of the extensometer, two fingers on the outside, and remove the extensometer. Press OK to continue the test. In the chart on the lower left, you can see that now the material is almost 100% in plastic flow. Very little work hardening is going on for this material now. We reach the maximum flow stress. And then the sample breaks. Once the sample has broken, the machine automatically stops data collection. We now want to transfer your data off the machine, either using a USB device or OneDrive. In the lower right, there's a list of data files. The newest file will be at the bottom of that list, but later it will be in alphabetical order. Export the file to the C Users MTest Quattro Desktop MEE-340 folder. And from there, you're going to upload it to OneDrive or some other convenient place, such as a USB drive, to get the data off of the machine. The last thing we will do is remove the sample. Open the safety doors on the jaws. And then turn the cranks. Once the jaws have moved far enough, the sample will fall out, so keep a hand on the sample. You have to turn the top crank quite far before the sample is released. You can see that the samples don't show any evidence of having slipped in the grips. They have nice, clean jaw teeth marks and no drag marks. You should protect the sample break surface in case you want to look at it later to study the failure mode. Finally, we press the Home button to return the crosshead to the home position. You can see the position is displayed in large type now. The crosshead returns to the home position, and that is the end. Time to move on to another sample. One thing that you may notice when you process the data is there seems to be lots and lots of extra displacement of the sample as measured by the crosshead. You cannot obtain a good elastic modulus from the crosshead position. During the linear part of the load displacement curve, the jaws are moving as well as the sample stretching. You can see this in this high-speed review of the data. I'm using the software to run the video fast forward and fast back. Look at all the motion in the jaws. So when you calculate your elastic modulus and your 0.2% yield stress, be sure to use the extensometer data, not the crosshead position.